this chapter, we're going to be looking at radicals. In this video, we're going to be looking at multiplying radicals.
All right, hi everybody. So now we're taking a look at multiplying radicals. Okay, and so like it says right here, when you multiply radicals, first of all, the index must be the same for each radical that you're multiplying together. So if you can multiply square roots by square roots, cube roots by cube roots, and so on. But the way I'm about to show you here, you can't multiply square roots by cube roots. Now it turns out you can do that, just not using this notation that we're using right here. You're going to have to use a different variation of that. So when you multiply two radicals together, you're going to multiply the coefficients. And so you take a look here. If you've got a root b times c root d, notice that over here we multiply the a and the c together, and that becomes the new coefficient. Then you multiply the radicands. So here we've got the b, and there's the d, and then all together here in the radicand here we've got bd. Now after you're done that, you should simplify as much as possible, okay? And so you've practiced doing that. So once you've got it in this form here, then you just approach it like you would any of those other simplifying radical questions that you've done. Now, it's often easier to simplify first and then multiply outside times outside and inside times inside. So that is really quite true. It is often easier to simplify first. Okay, to reduce the radicals, the two radicals that you're working with together first before you multiply them together. But you'll see some examples of that in just a bit. Okay, now when you're expanding a binomial, when you're squaring a binomial, okay, this is now going to be really important that people get this correct here. When you've got the square root of 2x plus 4 and you're squaring this, the mistake that people make is they assume that squaring is going to get rid of that radical. And while in one aspect of this expansion it does get rid of the radical, it doesn't actually get rid of it altogether. But that's because in most cases when people attack this, and it just is what it is. I wish we could get people to stop doing it, but it's so tempting here. You cannot distribute the 2 to both of those terms. If you've got a times b, let's say, squared, when it's multiplication in there, yes you can. That 2 can kind of distribute to both factors there, so it looks like that, a squared, b squared. But I cannot distribute an exponent over addition. It doesn't work like that, okay? And like I say in my class here, if somebody ever comes up to me and says, well, but you know what, I've always been doing it like that, I've always just distributed, then my response is, well, then you've always been doing it wrong. Okay, you've never done it correctly here. So we got to make sure that this makes sense here. So the easiest way to do that is just to take that root 2x plus 4, root of 2x plus 4 squared, write those factors out twice, and then distribute each term. Okay, so this root 2x gets distributed to both terms, this 4 gets distributed to both terms, and so when you multiply it all out, you actually get 4 terms total. Now, the 2 inside terms here are going to be like terms because they're both going to have that radical root 2x in it, which means I can add the coefficients together. And then here's where it disappears. So root 2x multiplied by root 2x will be root 4x squared, which has a square root of 2x. I mean, and that stands to reason. I'm multiplying 2x by 2x. Okay, its square root would be 2x. And then out here I've got 4 times 4 to get you the 16. Please watch out for that. Be very aware. If you're working through a problem on an exam, you got to be anticipating that we're going to ask a question like this and be looking for it. Don't get caught in that trap, okay? Anyway, let's take a look at some examples now. Okay, so now let's take a look at some questions here. We're going to multiply and simplify each of the following. Okay, so root 7 times root 2. Now my coefficients in both cases are just 1, so 1 times 1 is 1. And then root 7 times root 2 will be the square root of 7 times 2, which is just the square root of 14. Now, both 7 and 2 are prime factors there, and there's no repetition, so that is as simple as that's going to be. Over here, root 10 times root 10. Well, okay, there are a couple of ways that I can look at this and interpret it. I'll be consistent with what we've established up top here. This is going to end up being the square root of 10 times 10. But I can see right now that I'm squaring 10 in there. So, I mean, I know that the answer's got to be 10. But let's just carry on. This becomes the square root of 100, and then I know that that answer is 10. But I mean, I could have seen right here that that was going to happen because I'm squaring those square roots. Over here, I've got 3 root 5 times 6 root 3. Okay, so now we're starting to get, it's getting a little bit more complicated. Let's ask, can I simplify the root 5 or the root 3? And the answer is no, because those are both prime numbers, so that's as nice as it's going to get here. So now I'm going to multiply the coefficients together, 3 times 6. Okay, so 3 times 6 is going to be 18. And now I'm going to multiply the two radicands together, and 3 times 5 is 15. That is as far as I can go. I cannot multiply the 18 by the 15, just like I cannot multiply that 3 by that 5 there, in this case. And the reason for this is because this isn't a 5. It's a root 5. It's a very different number. It's related to the 5, but it isn't 5, which makes that a little bit more complicated. So this is about as nice as I can make that. Oh, I got a negative here. Okay, so now I'm going to be multiplying these two radicals together. And again, I'm looking, is there any way I can simplify those radicals before I do the multiplication? And again, they're both prime numbers, or it's the same prime number, so there's really nothing I can do. So I'm going to multiply the coefficients together. So negative 2 times 4 is going to be negative 8. And then 5 times 5 is going to be 25. Now, the more comfortable you get with this, the faster you're going to fly through this. I mean, I very likely didn't need to do that, but I know that the square root of 25 is going to be 5. Bear in mind that this is multiplied together here. This negative 8 is being multiplied by the 25. So when I take the square root, it's going to be negative 8 multiplied by 5. And so my result here will be negative 40. Oops. So this one right here, 3 root 6 squared. Well, I got to be careful with that square there. But in this case, it's not a binomial. This is just a monomial being squared. Because of that, that looks a lot like this, not like this. So here I can actually distribute the square through. So I can make that 3 squared and root 6 squared. So in this case, 3 squared is going to be 9. Root 6 squared is going to be 6. If you're wondering about that, well, let's just put this off to the side here. That's going to be root 6 times root 6, which would be root 36. And I already know that that answer is 6. And then 9 times 6 is going to be 54. Over here, again, I'm going to take a quick look at this. Is there any simplification I can do with the radicals before I do the multiplication? The answer is no. So I'm going to multiply the coefficients together. So negative 8 times 2 is going to be negative 16. 6 times 3 in the radicands here is going to be 18. But I can actually simplify the square root of 18 because I know that the largest perfect square that's a factor of 18 is 9. And I just got to think that through here because I go up my my powers there, my squares. It doesn't take long to get to that, and I get 9 times 2. So this will be negative 16 root. No, you know what? I didn't do that the way I wanted to. Let me just split that up a little bit. I wanted that to be root 9 root 2. And I know that the square root of 9 is 3. And whoops, wow. Highly suggestible today. Even to myself, I'm suggestible. Oh, whoops, you can't even see that. I'm sorry. And then 3 times 16 is going to be negative 48. So this will be negative 48 root 2. Okay, let's take a look at this question here. It says determine the following products. So all we're really doing here in this set of questions is just introducing a variable, but it really doesn't change anything. So 7 root x times 2 root x. Okay, I'm going to multiply the coefficients together. So 7 times 2 is going to be 14. And then under the radical here, I'm going to multiply the two radicands. Well, in this case, they're the same. So remember, x times x is x squared. Now, one of the common mistakes that I see here is people make that 2x. And I know people do that typically kind of because they're thinking about something else at the same time as they're doing that, and so they don't think it through properly. But yeah, x times x is going to be root x. Now, what's the square root of x squared? Well, x. Now, I'm going to let you know right here, that's not 100% true. It's not 100% true. Like, in what we're doing here, actually, this is there's a restriction here that holds here, because you can't take the square root of a negative. For these two expressions right here, there's a restriction here that x has to be greater than or equal to 0, and oddly enough, that carries through the whole thing. Now, I'm not entirely sure how picky people are going to be about this at this time, but it's just something to consider here. Okay, I have to restrict the variable to being a positive at the beginning, which means that restriction is going to hang out here at the end. Okay. Now, this one right here, again, same thing. Actually, it's almost identical in terms of the question here. 9 times negative 3, those are the coefficients, will be negative 27. And then this will be the square root of b squared. And then, again, when I take the square root, I'm going to be left with b. But even up here, there's this restriction that b has to be greater than or equal to 0 up here, because I don't want to be taking the square root of a negative. Okay? Now, it's not that the square root of a negative is undefined. Actually, it turns out it's quite well defined, but it's a non-real number. So we're just going to stick with real values here. So my answer here is going to be negative 27b, but I got to state that b has got to be greater than 0 for that to work. Over here, same sort of thing. It's just that my radicand over here got a little bit more complicated. I'm still going to multiply the coefficients together, so it's going to be 66 root x and then 3y. Now, there's not much I can do about that, but I don't like the way that looks there. And because order doesn't matter with multiplication, I'm going to make that 3xy. Now, in this case right here, I know that x has to be greater than or equal to 0, so does y. And this carries down all the way down to the end here. Now, here's the funny thing about this one, though. I didn't actually need to write these. In this case, I didn't need to do it, because once I get down to the bottom here, I can look at this. That restriction still holds. In fact, the fact that the x and the y are still under the radical here, just like they were up here, means that these restrictions still hold. In the previous questions, though, I need to state that restriction because I'm done with the radical. The radical has disappeared. It's no longer causing the restriction to occur. However, the restriction was in the problem at the beginning, and so it must carry through. I have to let that go through. Now, again, you're going to have to talk to your teacher specifically about how picky they're going to be with the marking here and what they're looking for, but that just gives you a sense of kind of how the math works. Okay, so in this problem we read that Amy and Rahima are determining the radical product 2 root 12 times 4 root 18. And then we read right here that Amy noticed that the root index to be the same in both radicals. So she multiplies the coefficients, multiplies the radicands, and then converts the answer to simplest mixed radical form. We're going to see her method below here. So we're going to take a look at what she does here. So we've got 2 root 12 times 4 root 18. Okay, so what Amy's going to do here is she's going to multiply the coefficients together to get 8, and then multiply the radicands together, and 12 times 18 is going to be 216. Okay, well, now I got to find the largest perfect square that is a factor of 216. So let's figure that out here. So 216, let's see, can we divide by 16? That seems like a good one. Nope. So I'm on my calculator here. 216 divided by, well, okay, 4. I know it can be divided by 4. That works. Let's keep going here. 216 divided by, well, it's not going to be 25. I know that. What about 36 here? Oh, 36 is the money. So 36 times 6.
Are you podcast?
And so now we can take this and split that apart here, because we know that this will be the root of 36 times the root of 6. And then the root of 36 is just 6. That's still all multiplied together. And then 8 times 6 is going to be 48. We've got that root 6 there still. Now, it says here, Rahima looked at the same problem, but notices that she can simplify both radicals first, then she multiplies. And then we're supposed to put her method here. So here's 2 root 12, and we're going to multiply that by 4 root 18. Okay. Now, 12, because of experience with this, I know that 12 has got a perfect square factor. That's 4. I also know that 18 has a perfect square factor. That's 9. So now this becomes 2 root 4 root 3 times 4 root 9 root 2. This is all being multiplied together, so this is going to be 2 multiplied by, well, the square root of 4 is 2, multiplied by root 3, times 4 times 3, the square root of 9, times root 2. And now here we go. We're going to multiply the coefficients together. So 2 times 2 is 4, times 4 is 16, times 3 is 48. Now remember, because everything's being multiplied here, I can do that. I can just multiply all of those coefficient factors together. The radicals then get multiplied together separately. So root 3 times root 2 is going to be root 6. And I get exactly the same result. You can see that right there. I get exactly the same result with either method. I think this one's a little bit easier though, because I make the numbers smaller before I multiply them together. Up here, the number got bigger, and then I had to try to simplify that. That tends to be a little bit harder. All right, so for this question, it says determine the area of the rectangle, expressing your answer in simplest radical form. Okay. So our area here is going to be the length, which in this case is 5 root 32, times the width, 2 root 16. Okay, well, if we've learned a lesson from the previous question here, we should probably simplify these things first. 32, okay, 32 is going to be 16 times 2. Okay, I think 16 is the largest perfect square. I mean, clearly, it has to be in that case. And then in this case here, the square root of 16, well, that's just 4. I can do that right away here. And then this is going to become 5 times the square root of 16 times the square root of 2. And then over here, I know that that's going to be 8. The square root of 16 is going to be 4 root 2 times 8. And now I'm just going to multiply the coefficients together. I'm still going to have this radical in there, because I can't multiply the radical by these integers. 5 times 4 is 20, times 8 is going to be 160 root 2. Okay, and whatever the units are, it's going to be that unit squared. Okay, for this set of problems here, what we're going to do is use the distributive property. And we're going to multiply all of these out here. Okay, so here I've got root 5 multiplied by the sum of root 2 and root 3. So that is going to be root 5 times root 2 plus root 5 root 3. Okay, so I will distribute that. And then I'm just going to multiply the radicands together and the coefficients, just like we've been doing here. But the coefficients are all 1 here, so that's just going to be 1. So this will be root 10 plus root 15. Here, do the same thing. We're going to distribute that radical to each of those terms here. Now in this case, though, bear in mind that there's this negative 1 that goes in front here. So it's going to be negative 1 times 4, so negative 4. And then this is going to be root 18, and then the negative 1 times negative 1 will be positive 1, and then root 3 times root 3 is going to be the square root of 9. Now, in the previous question, because these were primes, when I multiply them together, I'm going to get something that I can't, actually they're unique primes, I'm going to get something that I can't simplify. But in this question, I do have something I can simplify, because I know that 18 has got a factor of 9 in it. And I know that the square root of 9 is 3. So this becomes negative 4 root 9 root 2 plus 3. So negative 4 times 3 times root 2 plus 3. And so this is negative 12 root 2 plus 3. Now it took me a little while to get there, but I hope you're seeing what I'm doing in each step. And I'm only making these very little small incremental changes as I move from one step to another. Over here with this problem, I'm going to distribute the 4 root 6. And now that we're starting to progress through, I should always look to see first if I can simplify anything. And in this case, I really can't. And so now I'm going to distribute this thing through. So I'm going to multiply the 4 root 6 by the 3 root 2 first. So 4 times 3 is 12. Root 6 times root 2 is going to be root 12. 4 root 6 times negative 3 root 5 is going to be, well, 4 times negative 3 will be negative 12. And then root 6 times root 5 will be root 30. And now it's a matter of simplifying. Well, I know that 12 has got a factor of 4 in it. But you know, 30, there is no perfect square that's a factor of 30. Okay, so I'm going to have to leave that as root 30. Here, though, that 4, root 4, can sit there, and I'm going to turn that into a 2 in just a second. And so this will become 12 times 2 times the square root of 3 minus 12 root 30. And so 24 root 3 minus 12 root 30. Oops. And there you go. Now we're going to start to use variables here. And now bear in mind, the way this thing sits at the front here, there's this restriction here that x has to be greater than or equal to 0. Well, so does y. Both of those have to be greater than or equal to 0, and that's going to follow all the way down here. And now let's work it through. So when I distribute this thing through here, notice the coefficient here is just 1. So it's not really going to change the coefficients when I multiply it through. Now, root x times root x will be root x squared. And then 3, this will be root xy. Square root of x squared is just going to be x, so 4x plus 3 root xy. And remember my restrictions here. And remember my restrictions here. Okay. Now it's going to get a little bit more complicated because now we're going to have a binomial multiplied by a binomial. And when we do that, each of the terms here in this first binomial get distributed to the second binomial. Now, is there anything here that can be simplified before I get to that? No. So now I'm just going to distribute that through here. So root 2 times root 6 will be root 12. Root 2 times root 3 will be root 6. Root 5 times root 6 will be root 30. And root 5 times root 3 will be root 15. Now when I look at that, the only one that I can actually simplify at all is this 12 here. That's going to be 4 times 3 plus root 6 plus root 30 plus root 15. And so I'm going to try to do this a little faster. I've been doing it fairly slowly the last few questions here, but I know I could take a 2 out from that root 4, but that leaves me with a root 3 left over there. So 2 root 3 plus root 6 plus root 30 plus root 15. That's as good as it's going to get. Over here, oh, I got to be really careful with this one. It's a binomial being squared. So this has got to be root 2 minus root 5 multiplied by root 2 minus root 5. I set myself up for trouble if I just try to square that too quickly. So now I distribute both of these terms. So root 2 times root 2 will be root 4. Root 2 times negative root 5 will be negative root 10. Okay, the coefficient is 1 here. The coefficient is negative 1. That's the product. Negative root 5 times root 2 will be again negative root 10. And negative root 5 times negative root 5 will be positive root 25. Well, the square root of 4 is 2. I now have two identical radicals here that I can put together to get negative 2 root 10. Okay, there's a negative 1 there, negative 1 there for total negative 2. And then the square root of 25 is 5. So it's going to be 7 minus 2 root 10. Okay, let's just do a few more here. Okay, starting to get a little bit more complicated here. So now when I distribute this, and again, I'm looking to see if there's any simplifying I can do first, and there isn't. So now I got to worry about coefficients and the radicands. So 2 root 3 is going to get distributed to 4 root 2. So 2 times 4 is going to be 8. Root 3 and root 2 will be root 6. 2 root 3 times negative root 3 will be negative 2 root 9. 4 root 2 times 4 root 2 will be 16 root 4. 4 root 2 times negative root 3 is going to be negative 4 root 6. Now I want to simplify the radicals as much as I can. So inside here I know that the square root of 9 is going to be 3. And I'm going to try to speed this up just a little bit. The 3 times the 2 will be 6, so negative 6. The square root of 4 is 2 times 16 is going to be 32. And then I can't do anything with root 6. But now, because I've got like radicals here, I can combine the coefficients. 8 root 6's minus 4 root 6's is 4 root 6. And then negative 6 plus 32 is going to be positive 26. Go to the next one. Again, I'm going to look and see if I can simplify anything first, and no, I can't. So now I'm just going to distribute. So 7 times 4 is 28. 7 times root 6 is just going to be 7 times root 6. You can't do anything with that. Okay, I'm going to leave that coefficient out front. Negative root 6 times 4 will be negative 4 root 6. And negative root 6 times positive root 6 will be negative root 36. Okay, so this is going to be 28. Can't do anything with that. But 7 root 6 minus 4 root 6 is going to be 3 root 6. Remember, I'm just combining the coefficients. And then out back here, I know that the square root of 36 is just 6. And now I can put the constants together. So 28 minus 6 will be 22. And then I've got this positive 3 root 6. And now finally, we're going to look at 2 root 18 minus root 27 squared. Now, I recognize that square, and so I know I'm going to copy this binomial out to do the multiplication. But before I get there, I can see that I can simplify these. So this is going to be 2 root 9 times 2 minus the square root of 9 times 3. And I'm going to deal with that first. I'm going to deal with what's inside the parentheses first. Now, the square root of 9 is 3. And when I pull that out, it'll get multiplied by the 2. So it's going to be 6 root 2 minus, I can pull the 3 out, the square root of 9. So it's going to be 3, and there's still that root 3 left over. Now I'm going to write that out as the square indicates it should be. So that's going to be 6 root 2 times minus 3 root 3 multiplied by 6 root 2 minus 3 root 3. Okay. Now I'm going to distribute, and I feel fairly confident that I'm going to catch every term here. So 6 root 2 times 6 root 2 will be 36 root 4. 6 root 2 times negative 3 root 3 is going to be negative 18 root 6. Negative 3 root 3 times 6 root 2 is going to be negative 18 root 6. And I shouldn't be surprised that I see the exact same term twice there. Okay, that has happened almost every time that you've ever, every time you've ever seen a binomial squared, that's happened. And then finally at the end here, negative 3 root 3 times negative 3 root 3 is going to be positive 9 root 9. Well, the square root of 4 is 2, and 2 times 36 is 72. I've got minus 18 root 6, minus 18 root 6, well, that's negative 36 root 6. And 9 root 9, well, square root of 9 is 3, so it's going to be 27. And so finally, just putting those two constants together, 72 and 27 is 99 minus 36 root 6. And that's your final answer.